Hello, it's me, and I'm going to continue our journey through the corner turners. Once again, these are puzzles that don't turn at the face, like this 2x2 here, face turner over here, but those that turn actually where the corners are supposed to be as the axis of rotation. There's the Dinos and there's the Skewbs. And once again, to review, a Dino corner turner is basically a puzzle which consists mostly, if not completely, of edges. No actual corners exist on this, but the edges come together to form the corners about which the axis that they turn. A Skewb is a deeper slice that actually does contain corners, and when it turns, it actually rotates about the axis of the corner in the center, but drags the corners along with it, bisecting deep. The strategies are similar in terms of algorithms. It's pretty short on algorithms, but tall on strategy. So mostly they're down, down, up, up, because with only 120 degree turns, rather, there's really not too much moving around that you can really do in terms of individual pieces. Here, I can really focus on individual pieces. With these guys, it's more entire corners that end up turning, where I'm dragging a lot of pieces along with it. So we showed a interesting little hybridization between the Dino and the 2x2 with this Super X, and we went over the strategies that exist with this offspring between the matrimony of these guys being a face turner and a corner turner. So what I'm going to do is we're going to take the 2x2, the face turning out of it, and stick just with the corner turners and start to do hybridizations between these two. If I were to take hybrids of both of my forms of corner turners, Dinos and Skewbs, what would I end up with? Well, as promised, I'm going to start off with sort of a mixture between. A true hybrid puzzle has characteristics and complete independence of movements of both. Like the Super X can move on all angles just like a Dino, and on all sides just like a face turner. So I could just use it as a 2x2, just use it as a Dino, or use it as both. Well, somewhere between that is going to be the F Skewb. Now this is an F Skewb. This is from a Shapeways puzzle. Moves pretty well. The pieces kind of roll out on me a little bit, but otherwise it's a very, small, portable, and playable puzzle. This is not exactly a complete hybridization between these two. It has characteristics of both, but it's not exactly like both. This is actually more like a complete Skewb. So when you think about it, what I'm looking at is I'm looking at corners and centers and bisecting along the middle here. This does the same thing. Imagine this whole thing collectively is a center. Here's an obvious corner. These together, which look like the slices of a Dino, which can be used as such, if we look at these as corners, all of these as corners, just these as big ones, it moves pretty much like a Skewb. Notice that if I do it from this angle, axis is turning about this corner, and it's dragging these corners with it, this, and this. So it bisects down the middle just like a Skewb. What if I do it from this angle? Well, this is the corner. This looks really more like a Skewb. This whole thing collectively is a corner, and I can do Skewb moves like this. The basic difference between an actual Skewb and an F Skewb is that I have thinner slices that come up here. I've basically taken this corner and split it 3 ways so that I can make Dino slices. So the main difference is it moves and can perform exactly like a Skewb, but because I've got thinner, more shallow cuts, I can move some like a Dino. Now, I can't move it completely just like a Dino because all of these Dino pieces are non-intersecting. So this, what I'm doing is I'm moving it, it's kind of like a 4x4 AI cube kind of a thing, where these can't scramble as a Dino because they're non-intersecting. They're kind of like the caps of a Pyraminx, actually. So what they do is, instead of being scrambled as a Dino, what they can do is they can further complicate the scramble as a Skewb. So if I make a Skewb turn like this, and then a Dino turn like this, I've now scrambled it out of a usual Skewb state. So what kind of strategy will I have? Now I'm going to also give you a little bit of background. This puzzle, this version of the puzzle actually acted as a backdrop, which helped give me the organization of solving other hybrid puzzles. One of which was, of course, the Super X. Notice when I did the Super X, I basically solved it a corner at a time, where I'd put a corner in, say, here, then I'd do one here, then I did one here, and then I did one here. And the reason that I did that is I was creating corners that moved as independent dinos. So this corner was in, this corner was in. They're non-intersecting, as is this. Now I got that idea from solving the F Skewb, because here these are non-intersecting corners. So too with green here, this is already reduced, a corner's reduced, and it doesn't intersect with this. So that's the form of the solve that I did with this hybrid puzzle, and that's also the form that I'm going to do with other hybrid puzzles, including a full hybrid between the Dino and the Skewb. The Dino Skewb, so to speak. So this actually acted as the backdrop to this. Plus, the other reason why it's useful to go through this is because some mass-produced puzzles that are easily obtained are going to be solved exactly like this. It's the same strategy that I'm going to use. So to solve this isn't just an obscure, isolated thing. I'm actually going to be using this technique to solve other puzzles, one of which was the Super X. That was the inherent strategy. So what I'm going to do is I'm going to start scrambling this. Now again, remember, this collectively is like the center. This is just like a Skewb, basically, with shallow cuts. So we'll do a Dino cut here, we'll do a Skewb cut here, Dino move here, Skewb move here, Dino here. And I'm just going to go through some of the motion here just to show how this puzzle moves. Turn, turn. Now what I'm in essence going to do is I'm going to end up reducing this puzzle. And I'll show you what I mean, but you can see I'm doing Skewb moves and then the occasional Dino move to pull it out of its usual Skewb form. So right now this cannot be solved purely as a Skewb because I'm mixing it in ways that you can't mix with this guy. So turn, and I'll show some more turning of the puzzle. Just try to separate out some of these pieces from each other. Turn. So as you can see, the movement is actually very good. It could use a little bit of lubrication. I haven't done that because honestly, some of these pieces, especially the edges, are very loose. Pop out pretty easily placed back in, but can really distract you when you're in the middle of one of those highfalutin moves. Turn and turn. Okay, so it looks like that's a pretty good scramble. This is your scrambled F Skewb. And do a little more, maybe. Okay, so what then is my strategy? How am I going to solve this guy? Well, what I'd like to do is I'm going to actually take this puzzle and I'm going to reduce it to a Skewb and solve it as a Skewb. Now, I'll tell you, I actually have two ways of solving this. The first way that I worked out the solution to this puzzle, it was pretty straightforward. What I would do is I would just solve all my 4 Dino cuts, and then I just place the Dino slices in. And that was fine until I got to the last Dino cut. And that I was able to put together by using algorithms. So the thing about doing it that way, placing all the Dino cuts, is there's absolutely no parity with this, 0 parity. But the trade-off is there's one monster of an algorithm that I had to come up with in order to place this last one. It took me a while to come up with it, and it works, but it's almost impossible to memorize. It's consistent, but like I say, it's not exactly within the philosophy of how I like to solve these puzzles, relying upon a big old algorithm like that. So I had to bid farewell with it because it just wasn't going to be a good way of explaining how to do this. The other scheme, which is instead of solving it with the Dino cuts, reducing it to a Skewb, has no big algorithms. It's actually small on algorithms and high on strategy. It really has almost no algorithms, but there is the possibility of parity. And there's actually 2 kinds of parities. You can easily work through it, but it's there. So it's the way that I prefer because it requires no memorization, practically, and can probably be applied to other puzzles as well. So like with any reduction, when I reduce this to a Skewb, I might be reducing it in a way that doesn't exactly make sense. So here's how I do it. Here's how I worked it out. What I'm going to do first is I'm going to reduce the corners, then I'm going to reduce the centers. I already have reduced corners over here, here. So I can't just reduce it any old way because I could end up putting a corner in the wrong place. I could have a corner that makes sense here, a corner that makes sense here, but where they're positioned will make the puzzle unsolvable. I also have to be careful that I put it in rotated in the right direction. Otherwise, it'll also be unsolvable. It'll be like having one corner rotated. You actually saw an example of that with this puzzle, and we're going to have something similar here. So what I'm going to do is I'm going to use the corners that are already reduced, because this is really just half of a Dino and the rest is a skewb, already reduced to calibrate this puzzle. And that's the key here. I need something to calibrate this puzzle so that I can put everything else in conjunction with that. So I'm going to turn this here so this is okay in conjunction with each other. And let's see, I'm going to move this over here and this over here. It's kind of like placing the caps of a pyraminx. So these are okay and these are okay. What I'm going to do now is I'm going to put in these corners. So putting in this one first, this one, because I'm calibrating with these, has to be green, yellow, and orange. So what I'm going to do is I'm going to use skewb moves and Dino moves to set things up. So let's look for, say, a green and orange or a green and yellow somewhere here. Here's a green and yellow here. So I can easily move that in. It's going to take this out. I want to minimize that process as much as possible, which means I'm going to move this in. Well, actually, I happen to have both the green and orange and the green and yellow in here. So what I'm going to do then is just blast this up over here. I did turn this out. That could become a problem for me, so I'm just going to do one of these. All right, that might serve me well later. Maybe it won't. Who knows? Anyway, I just put this one over here. I moved kind of fast with that, but basically I've got these two greens here, yellow and orange. So I'm looking for the yellow and orange here, and I just move that into place. Okay, so this is in. This is reduced appropriately. What I'm going to do, and you don't have to do this, but I am going to just to demonstrate, is I'm going to turn this around so that it's where it needs to be. So move this over to here, orbit it so the green is where it needs to be. Right now it's not. I'm doing the equivalent of RIDIRD. This is all skewb techniques. Turn this like so, move it in. And now I move this guy back in over here. So this is correct. Got to make sure that these are fine. This is okay here. Let's just turn this over here. Try not to lose this as much as we can. It's really just to kind of demonstrate it. Even if we do, it doesn't really matter. Anyway, so now this is the green and red, which matches with this. I want the green and white, which is over here. So this just has to be turned around. So what I'm going to do is move this out like so. Then I'm going to turn this over here and just move it in and turn it back. Okay, now I'm looking for the white and red. White and red is right over here, and I just turn it in. Bang. So easy stuff. That's all in. I'm going to take this, I'm going to flip this over so that it's lined up with the greens, which means I'm going to take it out. I'm going to orbit it, bring it back down, bring this back down. I'm going to do it again. Take it out, orbit it around, bring it back down, and bring this up, just like I would do when putting in the corners of a skewb. Good, good, good. Okay, now that I have that done, we're going to turn it around and see how we're doing with these sides over here. Before I get this in, I have to make sure that these two are coordinated, and as you can see, they're not. So this will be an impossible situation no matter what's happening with these. These two may be up, these three may be up, but these two have to be coordinated, these two have to be up. Otherwise, it's going to be out of sync. No matter how you scramble this, these corners will always be in sync. So when I have a situation like this, sometimes it'll be manifest in a different way. You can see that this isn't correct. Another way that it might be manifest is like this. Like this, where both are down. But when I look at this, I see that this green one has to rotate counterclockwise. This one also has to rotate counterclockwise. That can't happen. With a true skewb, if this has to rotate counterclockwise, this one will have to rotate clockwise. So I know that this is out. So before doing any more center reduction, or any more corner reduction actually, I have to move this back into alignment here. So what we can do to visualize this is go ahead and just put one of these up. Let's go ahead and rotate this clockwise. We'll rotate it back into the previous position, rather counterclockwise. To rotate this counterclockwise, I start doing my clockwise down, down, up, up. So that's down, down, up, up, down, down, up, and up. Okay, so you can see this is up. So here's what I would do. This has to come into where it's supposed to be. This has to rotate up. So what I'm going to do, it's going to take this out for a second, but I'm going to rotate this up. Rotate it where it's supposed to be. Once I do that, what I'm now going to do is this has to come back down to here. So how I'm going to do that is I'm going to rotate it like so, do a skewb move to get it out of the way, then bring this Dino slice up, skewb this back, and now just put this back in. Now it would appear that I didn't cause any difference, right? This is back in, and this is still exactly the same, so what difference did that make? Well, the way that I moved it actually caused this green one to turn. It's the turning of that green one that actually helped reset things. So what I'm going to do is get this back in, orbit it up, turn it, bring it down, bring it back. You can see it's not quite in yet, so orbit it up. Turn it, bring it down, bring it back. So this is back, and now what happened is, let's see if these two got coordinated. To turn, this has to rotate clockwise, and this has to rotate counterclockwise. So that little strategy, not much of an algorithm, more of a strategy, set this right. So just to show that, what I'm going to do is rotate this. This has to rotate in a clockwise way, which means I'm going to do my down, down, up, up, counterclockwise. Again, purely skewb strategy. So down, down, up, up, down, down, up, and up. So you can see this is fine over here. Okay, now reducing these. At this point, it shouldn't be too very difficult. It looks like this is already in, but it's really not, because this has to be orange, not red, and this is white. So if I were to start from this angle, I want to get the blue orange one here, which is this one over here. So what I'm going to do to coordinate this is I'm going to move this in, do a skewb turn and a Dino turn to bring this back, and I will skewb this back. Now I'm not worried about these as of yet. It might look like I brought these out, but don't worry, this is over here. If it freaks you out, I could put this back in. I could go like this, turn, bring this up here, orbit it, bring it down, and bring this back. Just getting this green one back over here. You can see we're just fine here. So now we have a situation where these two are fine. Now I have to move the orange and white one in. If everything is right with the world, you're going to have two that are in, one out, and here all three are sort of jangled with each other, which is going to be a nice 3 cycle with exactly what I need. So what I'm going to do is I'm going to take this blue and red and put it next to where it's supposed to be. We got a red here, we got a blue here, and this orange and white is supposed to come into here. So let's move this out of the way here. I'm going to take this, do a Dino move to put it into here where it's supposed to be, then a skewb move to bring this back, and now a Dino move to return everything back to where it was. This puts this in, this is in, and all these are still reduced. All right, so with that done, what I'm going to do is I'm going to see if this is properly rotated. Because if I have an issue with parity, to get it out, I'm going to destroy any centers that I may have reduced. So let's go back to the green. This is good over here. Now, can this be rotated? Well, let's see. This here has to rotate counterclockwise. This has to rotate clockwise. So for all intents and purposes, it looks fine. But we got a problem here. We have 1 up and 3 down. So here's what happens when I put these back in. To rotate this clockwise, counterclockwise, I've got to start with my down, down, up, up, counterclockwise. So down, down, up, up, and then again, down, down, up, up. So herein lies the problem. You can see that the corners are in here. All these corners look fine, but this one is rotated. This one is actually rotated off by 90 degrees. Now we encountered something similar with this one, and I showed a way to get out of that. Now what I could have done is I could have solved it all up until the last one, and it would have looked really neat, something very strange that you never see with this. Everything's in except this is rotated. The only thing is, to get it back to rotate it, I would end up destroying some of the centers. I'd have to get them back. It became more cumbersome, so I've taken to do it this way, seeing if the corners are in first before going after the centers. And then if they're off, fix it so that it doesn't matter what I do with the centers. So here's what I do to get rid of this issue. What I really want to do is I want to take this and move it to here. So everything has to rotate like this in a counterclockwise way. So this has to come down to here. So that's what I'm going to do. I'm just going to move it down to here, this down to here. So I'm going to move it up with a Dino move, do a skewb move to turn this back here, then put this where I want it to be with a Dino move here. Now I've got this piece which actually belongs down here, so I'm going to continue to do another skewb move in the same direction here, do another Dino move to bring this up, which will align this, another skewb move, and then bring it back down. This will have rotated this and put this right back. Now I can see if that actually did the trick, to which you might say, uh-oh, this is out, but don't worry, this is out too, so it all works in the end. Bring this up, orbit it, bring it down, bring this back down here. It didn't work yet, so do it again. Turn, turn, and down. So this is good. And now we can see if this is coming into alignment. This has to rotate clockwise, so we're going to do counterclockwise rotation. No, actually this has to rotate clockwise, so we're going to do counterclockwise of down, down, up, up, down, down, up, and up. And as you can see, all the corners are now fine. All the corners are reduced. So the last part, center reduction. How to reduce these? Well, this is not at all unlike the reduction of a center of a cube. A reduction of edges of a cube, of a 4x4. It's exactly the same. You move it in, which moves this out for a second, bring it down, exchange it with a piece here, bring it back up, and turn it back in. So what I'm going to do is I'm actually going to take this, move it down to here with the Dino move, which will bring it there. Now what I'm going to do is I'm going to be taking this, moving this down here, replacing it with this, and bringing this up. So I want to do 3 at a time. If I were to put the right one into here, then I can substitute a yellow one here to bring up into here. So let's find a yellow one, which is over here. Now I'm going to turn this upside down, and the reason being, whatever is up here is going to end up here. And whatever is here is going to end up here. So if I wanted to solve 3 of them, I'd want to put a yellow one here, which will end up here. And then I'd want to put a green one here, which will end up, well, actually not a green one. I'd want to put a green one here so that it can end up here, but I'm all out of green ones, so I can't. So this will solve 2. The yellow will end up here, the green will end up here. So turn it down to match it up to here. Move this, do a skewb move to move it down, replace it with this, another skewb move down to here, and then put it back in with a skewb move up to here. And now take this and bring it back. And as predicted, this is in and this is in, so I put 2 in. Now I want to coordinate it to where I only put 1 in now so I can have 3 left. So let's see what we got. Well, here's an orange. If I move the orange down here, I'm going to replace it with the edge that comes over to here. I don't want it to be a red one over here because I'll end up putting in 2. And I'll end up with 2 left, and that's gonna get a little complicated. So what I'm gonna do is do exactly this, because this orange will come down to here, this will come up here and not be solved. And in terms of this blue will end up over here, so same colors. So move it down, then take this center, skewb it down to here, take this center, replace it down to here, so I'm replacing it with this. Now take this new center down here and skewb it back up here. And you find that I can now do the Dino cut back to get my corners back. Bang, this is back. And as predicted, we have this solved. So I should just have 3 solved. 1, 2, 3. So now I've got, whoops, well, that didn't quite work out. So I've actually got 4. So now I've got 2 left. So I get to show you how I do that. Well, I'm going to have a sacrificial lamb. I need 3 out, so that's going to be, say, this one. I'm going to take this, put it just above the same color, bring it down, then turn, 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 bring it up. Okay, that put 3 out. So now I'm going to do the same thing. And I'm going to take this, move it down here, find the red one, the other red one to put next to this. So that's going to be this guy. So go here. I'm going to try to coordinate that. Just like this, okay? So this will end up here. So I'm going to take this. So if you can imagine, this will come down to here to join the white. This orange is going to end up here, where this orange one is going to join it. This red is going to end up here. So move it down like so. Then we go turn, 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 and then move it up. And as predicted, all these centers are in. So basically, we have ourselves what should be a skewb, a reduced skewb. Same puzzle as this. But let's see if it operates that way. Let's see if we didn't mess things up a little bit. So I'm going to go ahead and solve it as such. Here's a center. Let's put in all of our edges. This one doesn't go in, but this one does. So let's move it down here. This has to come here, but it's orbited wrong, so turn it, bring it in. Next we put this in, it's orbited wrong, so I'm just gonna turn it, rotate it, and bring it in. And finally, the green, bang. So we have a green side, turn it upside down, and we're gonna put our centers in. Well, this is correct. The way that I do a skewb is now I do the opposite one here, whereas the yellow, it's here. I've gotta move this up. This will end up flapping to the side, but I'm looking for something that's within 180 degrees of where it's supposed to be. So I'm going to move this up with down, down, up, and up. This popped out and fairly easily can be popped in. Happens all the time. Anyway, this is up. I'm going to now put it into here, where this will then come up to here. So we have down, down, up, up. Now I'm going to put the white one down to here and go down, down, up, and up. Okay, so what we have here now is we actually do have parity, because this is in, this is in, this is in. These two are opposite. What I'm going to do is let's go ahead and put this down to here. So down, down, up, up. I'm going to take this orange, bring it down to here. Down, down, up, and up. Okay, I like the fact that these two are in, but here's the problem. This is in, this center's in, this is not in, and this is in, and this is not in. This red has to be here, this blue has to be here. So we have ourselves a bona fide parity of centers. So we saw rotational parity of corners. I've got parity of centers. Again, you won't get this in this puzzle. You won't have a situation where these two are flipped and nothing else. You have to have two that are flipped, because the law of cubes are still held to. No matter what puzzle it is, you still hold to the law of cubes, with some variations with the mix-up puzzle. So I can't just have one swap. It has to be 1, 2. So this is parity. So how am I going to get out of this? Well, here's how I figured that I'm going to do this. Basically, to swap these two, I'd have to swap these two, or these two. Basically what I'm looking to do is I'm looking to swap two centerpieces, because I somehow put them in wrong. So I'm going to take this and I'm going to move this down to here. I'm basically going to take 3 out. So I'm going to move this down to here and then go turn, 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 and move it back up. Now why did I do that? Well, I did that because now I want to swap. Remember it was red on the top. I want to swap one red piece for another red piece, always keeping the 3 out that are out. So now what I'm going to do is I'm going to take this and I'm going to turn this, I'm going to move this over to here so that this red is immediately under the other red. What I'm now going to do is I'm going to take this and exchange this down to here, making sure that this yellow is on the bottom, not on the top. If this yellow were up here, it would end up here, and I'd still end up with 2 pieces that are out and 4 pieces in. So this way, I'm still going to have 3 out. So this is going to come down, turn here, bring it down, put this one in its place, bump it back up, and bring it up. So corners are still fine. So what I did effectively is I kind of swapped my 2 reds. What I'm going to do now is I'm going to bring my reds back into proper configuration. So I try to minimize the positioning as much as possible. So I'm going to turn this here. Now I'm going to bring this red down to here because this in essence would have swapped both. On the other side here, I'm going to put my yellow one, but put the yellow one up here. So where's my yellow? It's over here. So I'm going to go like turn, and then turn. This has to be up here, so kind of turn it around, bring it down and across. This is just positioning. So now this will bring all these 3 back into alignment with hopefully the red having been flip-flopped. So turn it, then go down, down, up, and turn it back. So now we have our centers re-reduced, and now we can see what kind of a mess we made. So looking for green, here's the green here. Orbit this correctly, like so, and move it in. This has to be orbited correctly too. So turn, turn, and turn. So let's see what we got. We come back up to here. We like the position of these. This is within 180 degrees of where it needs to be, as is this. It really doesn't matter if this is up here. I'm going to move this to here. Down, down, up, up. This is in. Now I'm going to focus on the red piece. This will come down to here. Down, down, up, up. Now that I've done that, I'm going to focus on these, and already I can tell we're good because I have 3 out, so there's no parity with this. So I'm going to take this, move this down to here. Swapping these will predictably swap these, which is okay because then this is going to end up swapping with this blue. No problems. So we have down, down, up, up. So really I'm just down to a regular skewb solve. Then these 2 switch. Down, down, up, and look at that. I didn't even have to do my fancy corner turning thing. You saw it enough times and it's solved. Done. So very challenging puzzle, especially when there's nothing out there to really guide you. You really have to rely upon your experience with other puzzles, designing of new algorithms. If you're curious and if you're interested, I can show you the other way that I have of solving this. It's in many ways a simpler, somewhat more straightforward solve until the last one where you have to do a monster of an algorithm to move corners and move centers around. Kind of glad that I developed it. Who knows when I might have to use it, but it's really not the preferred way. Understand that this particular solve of the F Skewb is going to come back with other puzzles, but what I'm going to do next, having done this and organized the strategy of the F Skewb, is I'm going to take a skewb and a Dino and make a complete and full Dino skewb, which is going to look like this. There you go. Like this guy over here. We'll bring this little buddy over here. But basically this is a full Dino skewb. It's a monster and a beast of a hybrid. Can move as a skewb and move as a Dino in all directions, much like this could. So more on this next time. Thanks for watching.